Okay, so I talked about the Elgon project, and this is someone's Elgon project. I don't remember who made it, but it still works for the most part. And it's a really simple device, and it really gets across the idea of what the data acquisition system is doing. This right here is a variable resistor. That means the resistance will change. And it will change as you turn the dial, and it's really like a dial on your radio. If you, oh gosh, no one has a dial radio anymore, but it's like a dial that you turn, and you can change the volume on, something like that. It just changes the amount of resistance. It's hooked up to a 9-volt battery, and then it has this cable going to our junction box right there. Okay. The junction box connected to the A to D board, and I'm able to measure this voltage change for this device. Now, how this works is on the outer part here, these should not be touching each other. The outer two posts is where you put the power across, and then the inner post, and then one of the other posts is the variable part. And so what happens is, as these two rulers move apart, once they're connected to the potentiometer, and it changes the resistance. And as the resistance changes, the voltage that's being measured across here is changing. And that's what's ultimately being recorded over here. So I'm going to leave this Elgon out on the counter so you can find it, and you might want to try it. I will go through the program, although right now I'm not able to get the internet working on here, so I can't record it from the screenshot. So I've got to figure out another way to do that. But right now, we'll jump ahead and we'll look at this Elgon. All right, so now let me show you what I'm going to do, or what you can do. Let me do it like this. I'll put this over here, so hopefully you can see me. And so what I'm going to do is just take this Elgon. Now I'm going to hit data start, and I'm going to rotate it like this. Okay, and I can go back if I want to. And what we should see is a change in the data representing the different voltages that are being measured for each of these positions. Okay, so I'll start it here. I'm going to hit. I'll later on show you the data acquisition part. Okay, I'm going to hit go. I've got 5 seconds. I'm going to go up and back. Okay. Now let me show you what's on the screen. That right there. So this y-axis, in essence, right now, you see the numbers. They represent voltages. Okay, this is a voltage, this is a voltage, and this is time. And in essence, the voltage increased and then it decreased, and it's changing because this variable resistance is changing, and that it says that this is specifically a linear potentiometer, meaning that the resistance will change linearly with the dial. So as you turn it dially, turn it one way or the other, the resistance will change in a linear manner. Now, this stuff here, that's noise. That's noise. That's noise. And that's just because maybe our soldering job isn't that great. Maybe there's a little bit of noise in the system. Maybe that when they put this together, you have to take that cap off, and maybe the inside of the resistor gets a little messed up, but that's okay. This is just concept right now in terms of what the analog to digital board is doing. So what we would need to do is create a conversion factor between the voltage and the angle. Okay, let me show you how to do that. And what I'm going to do, I'm going to give myself a little bit more time. I'm going to give myself 15 seconds. Okay, and I'll go through how to do all this later on. And hit start. That's going to get ready. I'm going to put this over here. And what I'm going to do is I'm going to start this in this position, then I'll go to a known position. Now I should have a goniometer out. I'll go to 45 and I'll hold it there. Then I'll go to 90 and I'll hold it there. And then maybe I'll go up to 120 and I'll hold it there. And at each of those spots, I should get a voltage relative to a known angle. Again, I need a goniometer out to get these angles. And I could do smaller increments. I'd go maybe 10 degrees, 20 degrees, 30, whatever, okay? But I need to know those. I need to measure them. All right, so let me do that. Let me do it. I got 15 seconds. So I'm going to go here. Let's say that's 10 degrees. Maybe that's 20. Maybe that's 45. Maybe that's 60. And maybe that's 90. Again, if I'm doing a good job, I should get the goniometer out and get those specific. Then I come back over here. That's exactly, now I have voltages that go along with each of those positions that I had. Oh, it looks like the noise really starts up here as it gets more and more dialed in. So there's something going on with the potentiometer. But now I could figure out a conversion factor. I could figure out how many degrees there are per change in voltage, or the other way around. In this computer, we have to put in volts per unit. I think that's what it is. We put in volts per unit. Let me see. Okay, this is asking for units per volt. Okay, so it will be units in the numerator and volts in the denominator. So if this first position, if that was 10 degrees, I would put 10 degrees over whatever the voltage read, and that would give me a conversion factor. Now I would double check it for 20 degrees and make sure I get a linear response here. All right, so I would do it for a few positions and then probably take an average across those positions and then get a single value that would represent how many degrees per volt. So here's 0.25, maybe that's 45 degrees per 0.25 volts. All right, or that would be 45 times 4, so that'd be 20, 45, 160, 180 degrees per volt. And I would put that in for my conversion factor. And so if I actually do that, I'll put in 180. Right now I just put in 1 because I don't know what the conversion was. But now when I do that, and I do data collection now this number should represent degrees. All right, so let's do it again. All right, I got 15 seconds to work with here. And I'll do roughly again the same angles. Maybe that's 10, 45, 60, 90. Okay, I'll go back to 0. This should end. All right. Oh, that's not bad. So, there we do. One time slot. I can't remember what these moving cursor is. Okay. All right, so the first one, I went to 10 degrees. Oh man, that's not bad. 9 degrees. Now, that's a mess up of my conversion factor. I'm not being very exact here, but how cool is that? That's actually pretty close to what I was shooting for. All right, now let's go over. I think the next one I was shooting for 60. Oh, that's only 27. Oh, maybe I did 20 and then I did 60. Oh, look at that, 56. I was pretty good. I was eyeballing those. And then I went to 90. That's a little easier to hit. Oh, 93, not bad. All right, and then I forget what I did at that point. But these would just represent, oh, I think I did go up past that and then back to 0. All right, so that's all we do when we start putting in different devices, is we need to know the conversion factor, which represents millivolts per Newton. Well, now it's flipped around, but see, you got to always check your conversion factors. But these conversion factors for the force platforms, these are millivolts per Newton. All right, that's what we need to input for that. Let's see if I got another one here. Back Elgon. This is 90 units, 90 degrees per volt. That's what that one is. Let's go to an accelerometer. That is 0.10192 units per volt. In this case, that's G's per volt. All right. Now, just as a heads up, when you're in the device setup, never delete. You only add or remove from active. Never hit delete. I wish I had a piece of tape I could put over that button right there. Because those, what's nice about having all these instruments in here is they all have the conversion factors. And if we delete, then we have to go find those conversion factors again. All right, that's what these all are conversion factors. Okay, that's all they are. There's a goniometer. Oh, looks like that's the same goniometer, 90 units, 90 degrees per volt. Okay, so that's the fun of having a device like this, is it gives a sense for what the A to D board is doing. It's taking an analog signal, angle, over time. It's converting it to a digital signal in volts. And then we need to enter a conversion factor to be able to get the units, actual units of the device. Okay, that's a quick demonstration. I'll leave this out if you want to try it, or if you want to wait to make sure you know how to use BioWare, I will do a screenshot of using BioWare so that you feel confident about using that. Okay, thanks.